Now that we know what functions are, today we're going to look at what are the domain of our functions, okay? And what we do is we have to keep two cases in mind. The first case is that we cannot divide by 0, so we're kind of looking for fractions. All right, and anytime we see a fraction, we're going to set the bottom equal to 0, and when that happens, that's going to be bad, and we'll show you what to do here in a second. The other case, though, is that we cannot have negative square roots. So if we're looking for fractions in this one, in this one we're looking for anytime we see a square root. We're going to do something with that and show you why that isn't good either. Let's try some. All right, so we got a couple examples here. Remember, we're looking for either fractions or square roots. In this first one, I do see a fraction, so I'm going to set the denominator, the bottom of this fraction, equal to 0. And we'll solve for the x, because we're trying to find the domain. Domain's talking about our x values. So let's solve for x here, and this gives us that x equals a negative 1. All right, what this tells us is that we need to have all the real numbers in our domain except for negative 1. That's where the domain, if you will, is kind of broken up, or it doesn't exist at that point. All right, so we want to write this in interval notation. So if I want all the numbers except for this one, it's going to be from negative infinity until negative 1, right? Union with the other side of negative 1 going to positive infinity. All right, so this says every single number except at 1 itself. It's right, the parentheses means approaching 1, but never quite gets there. All right, so this would be our domain. In fact, you might want to put a D out there to show that that's the domain of that function. Let's try another one. Here in example 2, remember I'm looking for fractions or square roots. Do you see any? I don't. So this is going to be all real numbers, or you could say from negative infinity to positive infinity. Let's do 2 more. All right, example 3 is one that does have a square root. And remember, we don't want a negative inside of our square root. We could have a 0 or a positive number. So I can't just set it equal to 0. I actually have to say x plus 4 is greater than or equal to 0. So it could be 0, like I said earlier, or it could be something greater than 0, which is a positive number. And when I solve here, x, of course, is going to be greater than or equal to a negative 4. All right, so the domain of this function is going to be when x is greater than or equal to negative 4. Written in interval notation, the way that that looks like is going to be, since it's equal to, going to be bracket negative 4, and then it goes to positive infinity. All right, so number 3 is pretty straightforward because there wasn't anything too special on the inside, but in number 4, this one does have an x squared, so it's x squared minus 16. Let's take a look at this, at what happens here. Let's set this equal to 0 at first, and I'm going to show you kind of a little trick. All right, this says x squared minus 16 equals 0, just setting the inside of that square root equal to 0. And if I move the 16 over, now it's x squared equals 16. If you take the square root of this, remember the square root of something is going to be positive or negative. It's going to have those two cases, a plus or minus, or in this case, a plus or minus 4. All right, and so on a number line, what this would look like, if this is 0, we have negative 4 and positive 4. And currently it says that x could equal negative 4 and positive 4. So we know we're going to have like closed dots there if you think back to our inequality section. But then I have a few different regions. I have this part in between the two 4s, the part on the left side and the part on the right side. So let's kind of check a few numbers here. If I plug in 0, this number in the middle, into my original, does it give me something that is non-negative? In other words, would it be 0 or something positive? And if I plug in a 0, 0 squared is still 0. 0 minus 16 is a negative 16. So this middle section is not going to work. All right, what about the 2 on the outside? So I'm going to plug in both a negative 5 and a positive 5. And you should see pretty quickly that whether you plug in a positive or a negative, you're squaring that so you get the same result, 25. Okay, and 25 minus 16 is 9, and therefore you can take the square root of 9 and get something positive. So I think both here and here, this region will work. In other words, the graph of this, it would be shaded left past negative 4 and to the right past positive 4. But what does the interval notation look like? And remember, it's a snapshot of our kind of shading, and so it's going to be from negative infinity to the negative 4 with a closed dot. So this gets a bracket. Infinities always get parentheses. Union with another bracket 4 going to positive infinity.